So we have now learnt what to do when we have forces at an angle, right? We know how to resolve it. But let us look at how to apply it to different kinds of situations. So for example, now I have a 10 Newton force at an angle of 60 degrees and I want to find the acceleration of this object. What I will do is to say this is 10 cos 60, 10 cos 60 degrees. How much is this? 10 into half, cos 60 is half, so it is 5 newtons. So I will say A in this direction, so I will say AX, so this is the X direction, I direction. AX is 5 newtons because that's the only force divided by 5 kg, which is going to give me 1 meter per second square. Okay? Just hold on, we will see why I'm not finding AY. We'll see that, okay? Right now, that is the acceleration. I'm going to claim A is equal to 1 meter per second square, I cap if you want, I cap direction. Now let us take this question. Again, we want to find A. There are two forces acting like this. 20 cos 60. 20 cos 60 degrees. Cos 60 is half. So 20 into half is 10. So I have 10 newtons in this direction. 30 cos 37. Cos 37 like that. 30. What is cos 37? 4 by 5. Sin 37, 3 by 5. Cos 37 is 4 by 5. So how much is this? This is going to be 6 into 4, 24 newtons. Now if I compare these two, this is 10 newtons, this is 24 newtons. So 24 minus 10 divided by 5. So this is AX, but it is in this direction. So I will say in the direction like this. So how much is this? 14 by 5. 14 by 5 is equal to 2.8 meters per second square in this direction. Here the acceleration, I will write it as 1 I cap meters per second square. Here I will write the acceleration as minus 2.8 I cap meters per second square. Why minus? Because it was in this direction. That direction is I, this direction is minus I. Now, do you have a doubt? You should. For example, why did I not use J cap? I just wrote acceleration in terms of I cap. But remember earlier I said acceleration is net force by mass. But net force will have Fx I cap plus Fy J cap by mass. So you will have this and this, we will have both. But now what have I done? I have only done X. What happened to Y? Because Y is going to be 0. AY is going to be 0. First of all, how do I know AY is going to be 0? Because you see this is 10 newtons. The question does not ask me to find N. But 10 newtons, you know this is 50. Is this bigger or that bigger? This is bigger. If you did a component like this, 10 cos 60, this will be 10 sin 60. 10 sin 60 will be 10 into root 3 by 2. 5 root 3, which is less than, sin is anyway less than 1, so this is going to be less than 10. So this is 50, that is less than 10. So that means net force with these two itself is going down. Normal force will stop you from going down. But what is therefore the net effect of this plus this plus this? 0. So I already know that this is not going to go down or go up. So why unnecessarily find what the J component is? So AX is 1, AY is 0. So AX I cap plus AY J cap, this is 0. So answer is only AX I cap. So I don't want to find AY, I'll just simply find AX. Because I know that this is 10. If this was 100 newtons, then I don't know. Maybe it will go up. Then in that case, N won't be enough to stop it. It won't stop it. It will probably go up. Then I have to calculate AY also. If I take this case, this is 20, that is 30. If you take it together, it is 50. But this is 50. And then their components will be less than 50. So this is going to be less than 20, this is going to be less than 30, together it will be less than 50. It is definitely trying to go down. Normal force, this, 1, 2, 3, 4, together will be 0. So what is this direction acceleration? 0. So I don't need to find it, I'll only find the horizontal acceleration. Is that clear? Always this is correct. This is the correct thing you should do. But sometimes we are lazy. So we say, anyway Fy is 0. So I'll ignore. I'll only do Fx. Many problems, what we will do is instead of writing I and j, look at what I have started doing. I have said x, y. X separate, y separate. So if I have a force like this, we will kill that force and write Fx. This is F. Destroy F. Fy. What is Fx? F cos theta. What is Fy? F sin theta. But no F anymore, only Fx, Fy. If there was another force, again we will do F1x. Okay, maybe there is a force like that, F1y. We will take Fy's together and we will take Fx's together. Y does not affect x. X does not affect y. These two are independent. You would have learned this also in projectile motion. You learned this in vectors. X and y do not affect each other. Perpendicular forces need not be only x and y. If I tilt it like this and this independent. You do this separately, do this separately. For acceleration, you should combine the two, but many problems we will cheat because one of them is 0. So we'll drop whatever is 0. In this problem, this is 0. I don't want to find, I'll only find horizontal. In this problem, again this is 0, so I'll only find horizontal. But you have to be sure that it is 0. In these two cases, it was easy, so I knew it was 0. Now let us take another case where I have connected bodies. So suppose I have more connected objects and you are trying to pull, but with a force like this, then you might need to worry about it a little bit more. You have to look at tension and so on. So let us look at such an example. So in this question, I have a smooth floor and I have two blocks that are connected by a rope. You already know what happens when you have two blocks that are connected by a rope, right? There is a tension in the rope because if I'm going to pull this fellow, this guy starts to move, this rope becomes taut. In which case the rope will pull this fellow and will also pull that fellow. It will pull in both directions. So with a tension T. First, let us resolve this force. So this is going to be 20 cos 37. So 20 cos of 37 degrees. Always take this cos 37. Okay, 20 cos 37. So what is this? Cos 37 is how much? 4 by 5. So if I do 4 by 5, 20 into 4 by 5, that is going to give me 4 into 4, 16 newtons. Then there is also a vertical force, which I don't care about. The vertical force is 20 sine 37. It is going to be less than 20, but this is 30, that is 20, less than 20. So this is not going to fly off. No need to worry. Okay, in this direction, what is the force? 16. But there is also a tension force acting on the 3 kg block. There is also a tension force T, same T, acting on the 5 kg block. It is a frictionless floor, no other forces. Now, if the 3 kg starts to move with an acceleration A, the 5 kg will also move with the same acceleration. You know that it is connected. You can't say 3 kg will run off and 5 kg will remain here. Rope will break. So the rope is not breaking, so they will move together. Now let us write Newton's laws. MA in that direction. But what is the net force in that direction? 16 minus T. 16 that way, T is this way. If you want, I should draw this more carefully like this. 3 kg block, 16 newtons, T. And then separately, 5 kg block, only T. In the beginning when you are learning, you should do this. Afterwards, when you are doing this in an exam, you will directly write it like this. So it's always good to do this first. So it's very clear. 16 minus T. Why? Because the acceleration is in that direction. This also has the same acceleration. They move together. So for this block, MA, what is the only force acting on this? T. So T must be equal to MA. Now we have learned this, we have done many problems like this, except now you have this 20 newtons, you have to resolve, that's all. So if I add this, I'm going to get 16 is equal to 8A. So what is A? 2 meters per second square. So we've got acceleration A, 2 meters per second square in that direction, so 2I cap. Okay, but what is T? Well, you've got A, substitute it in here. So 5 times 2, 10 newtons. Notice this is 10 newtons. It is not 16 newtons. 16 newtons doesn't mean this will get 16 newtons. That is 16, this is 10, this is also 10. For this block, 10 by 5, 2 meters per second square. For this block, 16 minus 10, 6 by 3. 6 by 3 is 2 meters per second square. Is that clear? That's what makes these two equal. So I hope this is clear. So what we have done is, if there is a force like that, you resolve the force. You also have this extra component. You have to worry about that. But it is not flying away, so I don't have to worry about J component. If this was not 20, but it was 200 newtons, will I have to worry about the J component? Yes, because it will start to fly. But then it becomes very complicated, because this will start moving up. The rope itself will become like this. This may also start moving up. That's a very tough problem. You won't even come across that problem. Very rarely you will get a question like this in NEET, but you will definitely get a question like this with one block. Sometimes you may get it with 2 blocks. Okay, but if you have 2 blocks, you know what to do. Resolve this force. Once you have this kind of a force, you know this is 16, this is T, so you should be able to simplify. It's a straightforward idea. So best thing to do now is to apply these ideas that we have learned to many different kinds of questions. Just keep in mind that X and Y, this is the I cap, that is the J cap. These two, this is perpendicular. I cap does not affect J cap. J cap does not affect I cap. Now, in the beginning when I started by writing F is 3I cap plus 4J cap. Right? Things like this. But afterwards, I've stopped writing it. If you notice, I didn't write any I cap anywhere. I'm just simply saying this force, Fx, Fy. There is I cap, but it's laziness to not write Fx I cap plus Fy J cap. Too much work. So what we will do is we'll just write all horizontal separately, all vertical separately. We will call this resolution of forces. So we resolve the force into 2 pieces, and we will deal with one direction without worrying about the other direction. Later we may want to deal with this direction. That time we don't have to worry about horizontal direction. So hopefully that is clear. Resolve the force and then apply Newton's laws like we have always